Point 3 is going to discuss hypothesis test for a population mean. So when you're writing your null and alternative hypothesis, HO and HA, they should always have either mu, sigma, or P population parameters. Now the procedure that I've outlined here is going to flow just like it did with population proportions. We did population proportions on Monday, but it's still the basic same kind of principles. You're going to state your null and alternative hypothesis, so your HO and HA. As a reminder, HO has to contain what? What has to be part of HO?
Possibility of equality.
Possibility of equality. So less than or equal to, or greater than or equal to. That means HA, the flip side of this, is not going to contain the equal to possibility. It's going to be a less than, a not equal to, or a greater than. Those are the symbols that you should be using there. You should also be using either a mu, sigma, or P as part of these statements as well. Decide on the significance level. That's always going to be our step 2. That's pretty much going to be given to you. Occasionally, I'll let you use your imagination and choose between 0.01 and 0.05. Those are your typical values. Input the data. We're no longer doing the classical approach. I leave this here just so I can reference it every now and then if I want to. The classical approach involved a lot of extra work. You'd have to find the critical value from the Z distribution that separates the fail to reject region from the reject region, then calculate the test statistic, which itself was kind of a pain, then decide to reject or fail to reject. We can bypass a lot of that stuff by using StatDisk and the p-value. So once you input your data into the proper place in StatDisk, you can get a p-value, and based on the p-value you can reject H0 or fail to reject H0. To reject H0. I don't want to say prove H0 or conclude H0 because we're assuming that H0, the null hypothesis, is true to begin with. So we want to be careful about that. Last but not least, after you're done, you need to state your conclusion in words. So we'll take a look at that part as well. Now, as far as stating your conclusion in words is concerned, there's a little handout that I gave you, and you're free to use this handout on the exams. Just keep it clear of everything except your name. Now, in class, I'll number these A, B, C, and D, just so that we can reference them. But this is a guide to how you're going to state your conclusion in words. Now, your conclusion in words should not use any symbols. I don't want H0, I don't want mu or sigma or P. It should just be something in words that's friendly that somebody without a statistics background can read and make sense out of it. So we're going to put a lot of emphasis on that because a lot of what you used to have to do is done for you with a computer. Okay, so that's where we're headed today. Now, our first example here is actually really just making you think about the assumptions that you have to make in order to do a hypothesis test. So those assumptions, to kind of refresh your memory, was that either the population is normally distributed or n is greater than 30 or both. That's true. The value of the population standard deviation is not known. Again, that's true. The sample is a simple random sample. That goes beyond our ability to really test or discuss, so we'll kind of skip that. But what isn't a requirement is that the population mean is equal to 1. So if you want to choose something that's not a requirement, that one would be it. There's no requirement that your mean has to be 1. But we do have a couple other requirements that need to be addressed. And we'll look at those as we look at part B or example B here. 12 different video games showing violence were observed. The duration of times of violence were recorded with time in seconds listed below. What requirements must be satisfied to test a claim that the sample is from a population with a mean greater than 0.75? Now, just a quick little FYI, if you're to test that the mean is greater than 775, eventually you're going to have to write that as part of a null or alternative hypothesis. When we're testing claims about a mean, what parameter am I going to use to represent the mean? Anyone? Somebody said it. Mu. Mu is greater than 75. Would that be part of a null or alternative hypothesis? Yeah, that has to be part of the alternative hypothesis. So looking good on that one. Now let's take a look at our data and think about the assumptions that we have to make in order to do this hypothesis test. So those assumptions are kind of written right up here. Can we get very far before we run into some problems? What problems might we run into in looking at these assumptions?
Not more than 30.
Not more than 30. You can kind of eyeball that, right? It's not more than 30. Now, the other possibility is that it's normally distributed. And looking at this, it doesn't feel like it would be normally distributed with values out to 605 and then down to 0. I don't think so. But let's remind ourselves, how could you check if something has a normal distribution? What are the things that we've listed in this class to help us decide if it has a normal distribution? Yeah. All right, good. First one is a histogram. Wow, on a roll. Normal quantile plot. Yeah, excellent. If there's more than one outlier, it's probably not going to be normally distributed. No more than one outlier. And since you guys are doing so good on these, let me give you one more. This could be like a bonus problem or a bonus point here. There's something called the Ryan-Joyner test. Joyner might have a Y, I'm not sure. I think this is right, but I'm not sure. In any case, so there's a lot of different things you can look at to try and determine whether or not you have a normal distribution. And, I don't know. I'm not in the mood to actually plot this data. I don't think we really have to. Let's take a look down below. It says, what requirements must be satisfied? Check all that apply. Is there a requirement that you have to have at least one observation above or below 75? Is that a requirement? No, nothing like that there. How about B? Either the population is normally distributed or n is greater than 30 or both? Yeah, that one's surely there. The sample observations must be a simple random sample. Yeah, I got that one. Is there a requirement that the conditions for a binomial distribution be satisfied?
I stole it by accident.
No. We'd need a normal distribution under some circumstances, but no. So, are the requirements satisfied? I'm saying they're not. So that means it's easy to get rid of this one, and this one. Let's take a look at what's left and try and decide amongst A, C, and F as to which one we think is actually the cause of this not satisfying the requirements.
I vote C.
Got a vote for C? All right. So what's, oh, you just figured out a 1 in 3 chance of getting it right?
Yeah.
All right. All right.
I like my chances on that one.
Like your chance on that one? So, is there anything in this that requires us to have a binomial distribution?
No.
No. So, let's X this one out because of this binomial distribution stuff. So, I'll get rid of that one. Is there anything that requires us to have observations above 75 seconds? No. So I'll get rid of that one. So by default, Oz is right. The sample size is not greater than 30. The sample does not appear to be from a normal distributed population. There's not enough information to determine whether the sample is a simple random sample. All right, like I said, this is not going to be something that I'll be testing you on, but it is part of the requirements once you leave this classroom that you're going to have to check these things.
So who was right?
So, moving on.
Who was right?
Moving on.
Wait, I didn't hear you say who was right. Say it one more time.
One more time. All right. Let's,
That was such a bad joke.
yeah, it was a dad joke, sorry. Let's see. Let's skip over this for just a minute, and maybe we'll come back to that if we can. And actually do a test for example D. And I'm going to kind of veer off of this a lot. In particular, park officials talking about an eruption of a particular geyser. There's really only one geyser that people could be thinking of here. Does anyone know what that would be? It's in Yellowstone. Old Faithful. Old Faithful geyser. So it erupts regularly, probably a little bit more than every hour, or well, a little less than every hour, I guess. About 80 minutes or so, maybe, between eruptions. And the park officials try and predict when that next eruption is going to occur. But sometimes they're off. So you're going to see a prediction error. And that's what we want to test right now. And we want to test the claim that the mean prediction error is equal to 0. So let me highlight that right there. Claim that the mean prediction error is equal to 0. Okay. So that's your original claim. And we want to keep track of that original claim as we work through these things. So original claim. What would I write? How would I write the original claim in kind of a statistical way? Something that I could use on an exam. Yeah, mu equals 0. That's exactly what I was looking for. Mu equals 0. Now, let's run through our list of steps for a hypothesis. First thing is to state the null and alternative hypothesis. So you've got your original claim. Decide if that's going to be part of HO or HA. So this is going to be our first step. HO, HA.
Right. There's a possibility of inequality. Go ahead and say it.
It sounded like I heard you say HA.
You did not hear that. I said HO.
Okay.
Go
All
ahead
right.
and say it. I was right.
All right. So we got mu equals 0. What would be the opposite of that? If mu equals 0, what's kind of like the flip side? Not equal to 0. All right. Now, as far as the significance level, that's given to us right here. Mu is equal to 0.05, or excuse me, not mu. Sigma is equal to, how about alpha? Alpha is equal to 0.05. As far as testing this is concerned, we're going to input some data. And we can do that through StatDisk. So let's do that.
Bless you.
All right. Let's see. Stat test. Here you go. So you're going to want to find your way to data sets. And from data sets, you're going to go to 14th edition. And underneath 14th edition, you want to scroll down to 26. So one more time in StatDisk, you're going to go to data sets, 14th edition, and then scroll down to data set 26, Old Faithful. Should pull up your data right there, and great. We're looking good on that one. So step 4 is always find the p-value. So we're going to actually have to do a hypothesis test here. Now we haven't actually discussed how to do a hypothesis test for sample means yet, but let me see if you can kind of take a guess as to where you would go. Where would you go to try and do a hypothesis test here? Where would you think to go? Evan?
Hypothesis testing.
Yeah, hypothesis testing, which is under which menu? Analysis, hypothesis testing. Which one do I want? Am I testing a one sample proportion? One sample mean. Ooh. Hey, wait. Ready for this? Oz is right.
There we go.
Yeah, there you go. All right.
Clock it.
All right. So. Yeah.
And this is
Thank you.
recorded.
Thank you.
This is the second time it is recorded. Can't wait to play it back.
Yep. So let's take a look. We need to set up a couple things. First of all, we're not going to use summary statistics. We have the actual data. So let's click that. Then as far as we're concerned, which should be my alternative hypothesis? 1, 2, or 3? Which one you liking, Amy? Which one should be our alternative hypothesis in this one? So we had, this was our HA. Which one should I use here? 1, 2, or 3? Yeah, 1, looking good. Significance level is 0.05, we got that right. The claimed mean. Where do I find the claimed mean?
It's the same as your HO.
Yeah, you're going to get that from HO. There's your claimed mean. Sorry, I can only say it once a day.
That was twice. Thank you.
So your claimed mean. So we'll put in a 0 there. Population standard deviation. That's the parameter sigma. We don't know that. And typically speaking, you'll never know that when you're doing these kinds of tests. So just leave that blank. Let's select the prediction error for that column, prediction error, and do a hypothesis test. Does anyone remember what information that I need from here?
P-value.
P-value.
I could've said that.
P-value is just a bunch of zeros. What does that tell us about our actual hypothesis? What are we going to do? Are we going to fail to reject or reject? Let me rephrase it. Fail to reject H naught or reject H naught.
Well, that one I don't know.
Oh, wait, it's the same.
What's our little mantra there that helps us decide? Help me finish it off. If the p-value is low,
Reject the
H naught must go, right? So is the p-value lower than alpha?
No. Oh, wait, yeah.
Wait, so can we do this? Can we do Oz is wrong?
I was wrong. Go ahead.
All right. So the p-value is less than alpha. 0 is less than 0.05. So you're going to reject. Has anyone seen these little triangles with dots before?
No.
What that means? Means therefore. So therefore, reject H naught. Say again? Just if P is less than alpha. Our P value is 0. Our alpha value is 0.05. Here, let me write underneath here. 0, 0, 0, 0 is less than 0.05. That's literally what this is saying. Because of that, when your p-value is less than alpha, that's when you reject H naught. Okay with that?
Yes.
All right. Now we have to state our conclusion in words. I want this to be words that relate to the original problem. Okay, I don't want this just to be something generic like an AI robot would do. It's like, oh, we rejected H naught. All right, that's not the kind of thing that I want. First of all, you'll have this available to you, so you should be able to at least give it somewhat of a good go.
So
Then we're going to practice it. So which one do you think we're going to use here? Now this is where it's important to keep track of your original claim. So let me kind of circle that here. There's our original claim. Try and decide which way we're going to branch. We got mu equals 0, and that could branch to any of 4 different possible wordings of the conclusion. Take a minute, decide which one you think we should use. If you're watching this at home, maybe pause. In class here, check with a neighbor. Do you agree on which one you should use? What wording should we start this out with?
Okay.
but I also could be wrong.
Which one you got?
He's not.
It does.
Yeah, so it does change.
She said scratch that, run it back.
This is our original claim.
Yeah, I also thought
Does that contain the possibility of equality?
redacted.
So there.
No, I think it's such a, no, for real.
And what would the problem actually about?
Possibility of equality.
There is sufficient evidence to warrant the rejection of the claims to reject students.
Is that all?
Original claim.
The part that gets me is what we're gonna put from the problem.
Because the error.
Just says original.
Reject.
The state why though.
Reject our null hypothesis.
Relate it back to the geyser.
But what about the
We're not
guy?
doing it. It's the error percentage.
Wait, and what was
We
that?
can't just say we rejected it, relate it back to the geyser.
All right. So what are we looking at? What's sounding good for you guys? Which one is A, B, C, or D? A. Our original claim contains the possibility of equality or the condition of equality. So that's a yes. Out of this box, we branch to the right. Did we reject H naught? Yes, again. So you're going to start out your wording. There's sufficient evidence to warrant rejection of the claim that, and now we need to state this thing in words. Now I don't want just mu equals 0 or the symbol mu equals 0. Use actual words that come from the problem, and it's right here. The mean prediction error is equal to 0. That's pretty straightforward. So let's put all that together. There's sufficient evidence to warrant rejection of the claim that the mean prediction error is equal to 0. There is sufficient. These pens don't last at all. Sufficient evidence to warrant rejection of the claim that the prediction error is equal to 0. Nice. Okay. Looking good there. It's got all the little elements in this that I'd like, so yeah, pretty happy with that one. There is one more little bit of follow-up we're going to do on that. Before I get to there, are we okay with this conclusion? You can word it like that, something similar to that on an exam? John? All right, thank you. Now, there's one more thing that I want to draw your attention to here. In the output from StatDisk, they also gave us a confidence interval. In fact, they gave us a 95% confidence interval, and that's good. So let's take a look at our 95% confidence interval and see what we get. So we'll call it from negative 4.03 to negative 2.54. So we can be 95% confident I'm just throwing in a confidence interval on top of our extra work here. I want to demonstrate something here. So we can be 95% confident that the true mean prediction error is between negative, what was it, 4.03 and negative 2.54 minutes. Now, I'm going to ask you a follow-up question now that we calculated this confidence interval. The question is, does this confidence interval contradict our conclusion from our hypothesis test? Now, in our hypothesis test, we tested this, and we said that, yeah, mu is different than 0. Does this contradict that conclusion from our hypothesis test?
Yes.
Yes, it does.
I got a yes and a no.
You got a yes and a question mark.
Yes and a question mark? Well, we're saying that the confidence interval shouldn't contain the number 0, right? We're saying that, yeah, whatever the prediction error is, it's not 0. So our confidence interval should not contain 0. Does our confidence interval contain 0?
No.
It does not. So this conclusion and this one are consistent with each other. They match, they mesh. So it's reassuring to see that. It's not always going to happen, but most of the time it will happen. If it comes down to it, if you have to decide, well, I got to believe one of these, I don't know which one, believe your hypothesis test, not your confidence interval, if you had to choose one of them. All right? Now, generally speaking, I say 99% of the time, those two different pieces of information should match. But in the time that they don't, go with the hypothesis test. Any other comments or thoughts on that one? Let me just follow that up with one last thing here. Now, we're kind of lucky because our alternative hypothesis was not equal to. If your alternative hypothesis had looked different, let me just choose, claimed mean is less than, or the population mean is less than the claimed mean. Watch what happens to the confidence interval. All of a sudden, it's a 90% confidence interval. That doesn't match our level of alpha. Our level of alpha was 0.05. So if you needed to, you can always go back and run a confidence interval kind of from scratch. You can do analysis, confidence intervals, mean one sample, and let's see, we wanted to use the data in column well, prediction error, and then we'll do a 95% confidence interval, and we get what we're looking for. So if you need to, you can go back and do a confidence interval, and the nice thing is that it also gives you the margin of error, so get a lot of good things there. What are you confused about?
Never mind, sorry. Got it.
No, I'll be serious. If there's something you don't understand.
You had switched it already.
What's that?
I was looking at something different than you.
Okay. All right, so all I'm showing here is that sometimes, depending on your alternative, the confidence interval that they give you might have a different percentage. They might give you a 90% or a 98%, depending on your value of alpha. So if you need to, just go back and do an extra analysis. Okay. Let's keep going. Let's remind ourselves of a data set we worked with a little while ago, and that was the human body temperature. What's the average human body temperature? At least the value that we grew up with. 37 degrees, great, nice, I'm impressed. 37 degrees Celsius, which converts to 98.6 degrees Fahrenheit. So here's our original claim. The average human body temperature is less than 98.6. I don't believe that old, century and a half old statistic. I think it's less. So there's your original claim. We'll test it at the alpha equals 1% level. But start with your original claim. Write that claim down in terms of an inequality, and then figure out what HO and HA should be. So HO and HA, write both of those down. Original claim
Is this still 8.2 or 8.3?
This is 8.3. Now, if you're testing claims about an average, what parameter would that be? Mean. So what symbol do we use for this claim? Mu is less than 98.6. Royale, what hypothesis does this have to be part of? Alternative hypothesis. Good. So that's going to be mu is less than 98.6. Bashir, if that's my alternative hypothesis, what has to be in the null hypothesis? Need a little more. Okay. So Nick's chiming in with greater than or equal to. You agree with that? Yeah. So it has to be one or the other. Notice there's no way for both of these things to be true. You can't have them both true. So, all right. Mu is greater than or equal to 98.6. Let's test this claim at the 1% significance level. Setting the bar high here for us to reject H naught. Oops, other way around. Step 3, we're going to have to input the data. Sort of. We're going to take a little shortcut to inputting the data. So our data in this case is going to come from another data set. So go to StatDisk, open up data sets, 14th edition, and then we want body temperatures. So data sets, 14th edition, data set 5, body temperatures. Nice. Now you got your choice of body temperatures. You know, do you want to do it first thing in the morning? Do you want to do it later in the day? Day 1, day 2? We're going to use day 1 at 8 a.m. And you know what? I'm in the wrong spot. I need to go to hypothesis testing. I was at confidence intervals. So, analysis, hypothesis testing, mean one sample. Click Use Data. And let's see. Click Use Data. What significance level did we choose? We chose 0.01. So let's change that. How about our alternative hypothesis? Which one do I want there? 1, 2, or 3? All right. Oz is suggesting 3. Do we agree with Oz?
Yeah.
Is Oz right?
Yeah.
Wow. All right.
Yeah, love to hear it.
All right. So there we go. What's the claimed mean here? What should I use for the claimed mean? 98.6. Yeah, that's right. 98.6. Looking good there. We don't know the population standard deviation. Typically you won't. We're going to use day 1 at 8 a.m. for our data. And bam, evaluate. So input the data. Check. Step 4. What do I need here from step 4? P-value. Colin, what's the p-value? Yeah. So our p-value is 0.00022. And in step 5, we got to decide if we're going to get rid of the null hypothesis or not. So we're going to decide if we're going to reject or fail to reject. So, Nick, what do you think? Reject or fail to reject?
Reject.
Yeah. Our p is less than alpha. P is less than alpha, meaning 0.00022 is less than 0.01. So reject H naught. On the test, please put reject H naught, not just reject, because sometimes people put reject HA, which would be wrong. Last but not least, we need to state our conclusion in words. So this is where it's helpful to have your original claim kind of written out for you, or maybe you just want to circle one or something like that. But somehow or another, remind yourself what the original claim was. And then put that to the test. Figure out which one of these you're going to use. So one last look at your original claim.
I did it. Yay.
Yeah.
Yes, ma'am.
Oh, you love to hear it. I've never read that. I gotta suck it up like that.
Derek, let's work through this together. Does your original claim contain the condition of equality? Does not. All right, so which way am I going to branch? To the right or down down. Did we reject H naught? Yes. So the wording should start out here. The sample data support the claim that, and then we just need to put the original claim in words. So you should have something like, the sample data support the claim that the average human body temperature is less than 98.6 degrees Fahrenheit. So there's your conclusion in words. Now, if I'm using alpha equals 1%, what level of confidence corresponds to alpha as 1%? 99. A 99% level of confidence would correspond to a 1% level of significance. Now, let's take a look at the output from StatDisk. What kind of confidence level did they give us? Here's a 98 one. That doesn't exactly match what we wanted, which was a 99% confidence interval. So if you wanted to follow this up with a confidence interval, go to Analysis, Confidence Intervals, Mean One Sample. We're still going to use data from day 1 at 8 a.m. We want to make that a 99% confidence interval to match our 1% level for alpha. And there you go. So our confidence interval, we can be 99% confident that the true mean human body temperature is between 97.8 and 98.5. 7.8 and 98.5. Yeah, I just wanted to copy down these numbers while I had them, but we can be 99% confident that the true mean human body temperature is between 97.8 and 98.5 degrees Fahrenheit. So, yes?
No, go ahead, maybe you might answer my question.
My question is going to be kind of the same as it was with the last problem. Does this contradict our conclusion from our hypothesis test? Or does it match our conclusion? Which one do you think?
I'm gonna go with matches because that's what she said.
Yeah, this is true.
Yep, you smart.
So we rejected this possibility, right? We said, no, this is what's true. Take a look at our confidence interval. Both of these values lie below 98.6, right? We think that the true mean human body temperature is somewhere in here. We don't know where, but it's somewhere in here. And since both of those are less than 98.6, that's in line with our conclusion from our hypothesis test. So it's nice, it's reassuring to see that those two things match each other. Looking good on that one, AA? John?
So are you going to want both the confidence?
If I want both, I'll ask for both. I've just been doing that because I want you to be in that habit of, well, I mean, not so much the habit, but I want you to have that understanding that generally speaking, those should match. Okay? Anything else? Whew. All right. All done then.